Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Welcome friends, greetings of the day. This is the course offered by Swayam Prabha at IIT Gandhinagar. Maritime structures under special loads like fire, blast and explosion loads. It's a specific kind of a course content which is highly industrial oriented and improves the job prospects of people who undertake this course. This is one of the core courses, that is the subject being taught in the master's program in maritime engineering at IIT Gandhinagar, a unique program in the country in maritime engineering in IIT system which is just recently started, and it is completely industry oriented and very effectively planned and designed for improving the capacity building in maritime sector. I wish that you register for this program and undertake these courses in presence at IIT Gandhinagar, the Department of Maritime Engineering, and get the maximum benefit. Okay, continuing the lecture content what we had in this course, now we are discussing on lecture 10 where we will discuss and learn more about the explosion characteristics and specifics related to hydrocarbon fire. The moment we talk about explosion, the most vulnerable and dangerous explosion which could happen in maritime industry, especially in offshore platforms, processing platforms, LNG storage carriers, etc. This is one what we call as BLEVI. So, this is boiling liquid expanding vapor explosion. Friends, this is one of the most vulnerable and devastating explosion that could occur in processing plants, LNG carriers, even industrial plants where LNG, CNG are stored and processed. So, this is one of the, in fact, even in coastal harbors where LNG cargo is handled. In the recent crux of the shortage of LNG gas, we already know that how the LNG gas are handled in cargo along the peninsular part of the country, especially in Gujarat coast in particular. So, there is a huge demand of logistic management and maritime sector under such emergency situations. So, a small error which could cause a devastating accident is to be understood very carefully and planned and executed. So, we have to be very prepared for this kind of explosions which could happen accidentally on the coastal sector or maritime sector when you handle vulnerable liquids like LNG or CNG. So, friends, LNG or BLEVE is one of the most vulnerable explosion that would happen. BLEVE occurs under pressurized or when a pressurized container holding liquefied gas. It is a very specific kind of explosion. Liquefied gas, for example, propane, butane, etc., are exposed to intensive external heat. Okay, the source of fire here is actually the heat. So, what happens is this heat actually weakens the container walls of the vessel and it induces rupture, and that creates instantaneous boiling of the contained liquid, and the specific difficulty here is when they start boiling they expand too high and that causes explosion. So, BLEVE is one of the most vulnerable accident one could face. The violent expansion of vapor leads to catastrophic explosion. That is why it is called BLEVE, the boiling liquid expanding vapor explosion. And the consequence is it throws or disperses the debris including the metal components of the vessel into far distances at high velocity. This can cause physical and fatal accidents to people who are staying around this. The tragic Blavi accident happened is San Juanico disaster in Mexico. One of the example could be example of the most tragic accident of Blavi happened is in San Juanico. Disaster happened in Mexico in the year 1984. Actually, the container or the containers having LPG, liquid petroleum gas, in a refinery facility exploded in series, one after another. The disaster began when a leak in the sewage system ignited, generating intense heat that weakened the structural integrity of the pressurized LPG storage tanks. When the tanks ruptured, the sudden release of liquid gas led to instantaneous vaporization, creating massive fireballs and shock waves, which has resulted in Blavi. The explosion obliterated the facility, engulfed nearby communities in flames, and caused resulting about 500 fatalities, instantaneous death, 500 fatalities, and about, let us say, 10,000 people injured. Huge extent, huge extent. This catastrophic event highlights the severity of the risk involved. We cannot make a design as explosion proof. We can only prepare the emergency planning and fire protection measures under such unexpected accidents. So, early leak detection and adequate emergency response planning. So, we should say early leak detection and adequate emergency response planning. Would help us to mitigate such effects. The consequences. We cannot address the causes. Because they are actually accidents, real accidents, which are beyond the control of human. Sometimes there can be a leak, there can be electric short circuit and fault, etc., because of oversight during the shift operations. So, causes for accidents can be prevented to some extent, but they happen because they are accidents. What we can work out is we can reduce the consequences. Actually, risk is a product of cause and the consequence, okay, or the number of occurrence, cause related to number of occurrence, period of occurrence, frequency, and we can now here work out on consequences and reduce the risk. The next one, which is equally dangerous, is the vapor cloud explosion, which we briefly say as VCE. It is another hazardous phenomenon which is associated with accidental release of large quantities of accidental release of large quantity of flammable gas or vapor. Actually, when it disperses in atmosphere, it forms a cloud. We call this a vapor cloud, and this cloud ignites and causes explosion. So, an instantaneous large quantity release of flammable gas results in a vapor formation. And this vapor explodes because it is ignited by some fire source. And when it explodes, that becomes vapor cloud explosion, which is very serious. One classical example of this, which is referred in the history of accidents, is Buncefield fuel deposit explosion. Fuel depot explosion, which happened in United Kingdom in the year 2005. It is a remarkable accident which is caused because of some power fault happened in the storage area and caused destructive power of vapor cloud explosion. Actually, this explosion resulted from ignition of large fuel vapor cloud which was stored in the depot, and this severely damaged the adjacent buildings. And infrastructure. Therefore, friends, understanding explosions like deflagration, detonation, levy, vapor cloud explosion are very crucial for designing maritime structures to withstand these kind of accidental loads. Having said this, let us now talk about the consequences of fire and explosion. Fire and explosion significantly impact structural safety. Safety and also human lives. With the severity and consequence varying depending upon the context and environment. If it is residential or commercial building, then fire can lead to structural weakening due to prolonged exposure of higher temperature. They also lead to loss of life, serious injuries, considerable property damage, etc. But in industrial settings like maritime structures, chemical plants, offshore oil and gas exploration installations, hazards associated with fire and explosion escalate dramatically. Because the reasons are a high presence of volatile, flammable, explosive or gas in the vicinity. Like we have seen two incidents, one in UK and one in Mexico. These are all a large amount of inventory being stored and stocked in the depot, which accidentally got fire, and that resulted in Levy and VC. So, this caused a severe damage to infrastructure, considerable economic loss, and very significant environmental pollution. Therefore, friends, processing industries which encounter levy, which occur when pressurized vessels containing liquids are exposed to external heat, need to be also checked for their design and evacuation safety. Now, let us see what are fire vulnerability factors. What are the fire vulnerability factors? Maritime structures, especially offshore oil and gas exploration processing platforms, are susceptible to fire due to the nature of operation they hold in the presence of flammable substances. Therefore, there are many factors which are associated to the vulnerability of fire. One is, of course, predominantly huge presence of hydrocarbons. The primary risk essentially comes from here. Is associated with the presence of this. Furthermore, the second risk factor which comes in hydrocarbon is the temperature, because the high temperature process, the temperature in regasification or oil and gas processing touches as high as 1200 degrees Celsius, very high temperature process. Therefore, this can cause ignition within minutes. So, there is no time available to plan a firefighting. Okay, that is the major risk here, because the fire ablazes and sets and grows within minutes where the temperature is so high. The second factor, vulnerability factor, is the presence of electrical equipments. We deal with huge electromechanical equipments on top side of the platform, even the cargo handling on maritime sectors like ports and harbors, etc. So, any electrical fault because of poor maintenance, because of improper design, because of operational fault can lead to electrical faults. It can categorized as short circuit, equipment malfunctioning, and this can produce spark which can ignite the flammable liquid and catch fire and cause fire or explosion, as the case may be. The next factor could be the process equipment failure. Failure can also happen when there is a equipment failure in the process. Examples could be compressors, pumps, separators, etc. They can also fail, and this will lead to, when they fail, it will lead to over pressure conditions which can cause rupture or a crack, which results in leak of the stored flammable liquid or gas. So, that can be another vulnerable factor. The fourth one could be operation takes place at high intensity of heat. So, one of the source for fire is already present in a large vulnerability, because activities such as welding, cutting, what we call flame cutting, or grinding, which are very common construction fabrication activities that can happen on offshore topside or even on heavy industrial structures, maritime structures, they all can generate heat. They can also cause spark, which can create serious hazard for risk. Hazard for fire, sir. For fire. The next factor could be gas release. Uncontrolled gas release can also happen sometimes. This can also cause explosion and environmental pollution. Of course, nevertheless, we also have to include the human error or oversight. Mistakes in operation, unplanned maintenance, improper shift handovers, untrained personnel, all could lead to human errors in causing these accidents. Then the other factor could be a large inventory. That is, sometimes we also have a stock of flammable material in place. That is another factor which can also cause fire, because it increases the potential risk for fire. So, this can be due to improper storage, improper handling, which can lead to spill or leak of the flammable liquids. The last factor which is also resulting in fire is the module arrangement. Module arrangement is the structural design and the architectural layout of the configuration, the geometric configuration of various functional activities on a maritime unit. Okay. There can be a possibility of fire spread within and between the units. So, we must plan what is called horizontal zoning and vertical zoning to avoid consequences of fire. So, one can also see this as a simple layout diagram as you see on the screen. Fire vulnerability factors can come from various sources, as we have just discussed. All of them are put in one shot, and all of them have equal contributions for the fire accident. Okay. In summary, if I say that maritime structures, especially oil and gas platforms, offshore topsides. They are most vulnerable structures which can have a high potential for catastrophic fire scenarios. Now the question comes, what are various fire scenarios? So understanding fire scenario is very crucial for effective risk management under fire. So engineers and safety professionals can implement robust preventive measures and emergency response protocols by comprehending to these scenarios. Let us see what are those common fire scenarios which happen in a process industry, nevertheless in a maritime structure as well. So one is what we call as cellulose fire. It is one of the fire scenario. This fire arises from combustible material such as, example could be insulations, wooden furniture, or any organic materials present in the inventory. They can quickly spread fire if not contained. The second could be, same scenario could be hydrocarbon pool fire. We already saw very briefly about the pool fire. When hydrocarbons accumulate in a liquid form and ignite, it causes fire. These fire can reach extremely high temperatures and pose a very significant threat to the personnel and equipment. The third could be jet fire. The third scenario could be a jet fire. This scenario occurs when a pressurized hydrocarbon escapes and ignited. They develop very high density and high velocity jet flame. The adjective jet itself is a reference that they move in a very high speed. They are capable of causing extensive damages to both structures, equipment and human. They are very dangerous. The next could be fireball. There is another scenario. Fireball is a sudden explosive release of flammable gas. Or basically a vapor. It occurs when a cloud of gas or vapor mixes with air and ignites. So, this forms a ball shape and travels along with air with high velocity. They can result from equipment failure, leaks in pipelines or blowouts. The other scenario could be flash fire, flash fire is a very rapid intense fire which spreads on a wide area. They occur suddenly when a flammable mixture ignites. Flash scare can happen even during maintenance. It can happen during welding, cutting, grinding and planing operations, which are very common industry based operations which happens on offshore topside. The other scenario could be high heat flux fire. These fires are characterized by intense heat radiation, they can affect nearby areas if they are not directly involved in fire. This can lead to secondary ignition of material, which otherwise were not intended to catch fire directly. So, which are located adjacent to the fire source can also catch fire due to this. The next scenario could be the cascading events. Fire can trigger secondary incidents. For example, explosion of or structural failure. So, what happens is the interconnected members, structural members fail, and that can cause structural collapse of the unit. So, we call this as cascading event. So, friends, a few accidents which are rememberable in maritime sector need to be also revisited for our knowledge sake, and then we can also learn lessons from those. Let us see a few of them very quickly. The one which is remembered by almost all maritime and offshore engineers is Piper Alpha disaster, happened in 1988. This actually occurred in North Sea off the coast of UK. It serves as a stark reminder of the consequences of safety lapse. So, this accident is a very good indicator of so many safety lapses happened in this. It is triggered by a gas leak resulting from maintenance error, friends. The fire was triggered by gas leak which happened due to maintenance error, routine maintenance. There was an oversight in that, and that caused series of explosions. It has resulted in a very severe impact. It lost 167 lives, people died. It caused extensive damage to the platform. The damage was estimated to a financial loss of 1.4 billion US dollars. That was the order of the loss created by this accident. The fire remained in rages. For 21 days, it could not be controlled. Thereafter, it was finally controlled. Piper Alpha underscored the critical importance of robust communication, rigorous safety protocols, and preventive measures to prevent such fierce accidents in offshore operations. The second one, which is also remembered, is the Deepwater Horizon. Deepwater Horizon happened in Gulf of Mexico in USA in the year 2010 during drilling operations. A catastrophic blowout triggered this failure. Tragically, 11 workers died on the spot. There was an extensive oil spill which happened on the sea, and this resulted in severe environmental damages. So, this again underscores an importance of preventing such accidents and understanding the consequences, which can also create a financial loss and environmental impact to the surrounding area of the platform or the vessel. The next one remembered is Yenchova platform accident occurred in 1984. This accident occurred in the off coast of Brazil in 1984. This is again experienced due to blowout. There is a sudden release of pressurized hydrocarbon. Which resulted in this blowout. It lost 42 tragic lives, severe financial loss, and the rescue efforts took place for at least about 15-20 days to control this accident. The incident underscored the importance of blowouts in offshore drilling operation. The other one happened in India, Bombay North, what we call Bombay High North, happened in Arabian Sea. In India, the Mumbai High North platform faced a devastating incident. This has occurred because of collision of a support vessel. This caused rupture of pipelines and that resulted in leak of gas and that resulted in subsequent fire. 22 fatalities and significant environmental damage caused by the spill. So, friends, significant fire accidents give you critical reminders about the risk involved in such events. Okay? The lessons what they convey are very clear. One, they are good indicators of the likely risk associated with such accidents. They also emphasize a proper stringent safety measure to be practiced in such scenarios. It should have effective communication systems, preventive maintenance, and robust emergency protocols. All should be in place to mitigate the effect of such hazards. Therefore, friends, offshore topside and maritime structures, port and harbour, who acts as storage areas, offloading, onloading, LNG, CNG vessels or containers, etc., are all vulnerable to such accidents. There are numerous fire risks coming from various sources, including hydrocarbon releases, electric faults and hot work operations. So, one can say the principal sources of fire and explosion accidents come essentially from electric faults, principal sources only, okay? Hydrocarbon sudden releases, and hot work operations like welding, grinding, cutting, etc. So, one has to be careful when performing these operations and one should ensure highest safety practiced in such cases. Having understood this, friends, let us talk some essential features of hydrocarbon fire. Why this fire is special? Why hydrocarbon fire is special? Okay. Hydrocarbon fire is a specific type of fire fueled by hydrocarbon compounds predominantly occurring in industrial settings within oil and gas sector. Hydrocarbon are organic compounds composed solely of hydrogen and carbon atoms. These molecules form backbone of fossil fuels, petrochemicals and various industrial substances. One of the major concern with hydrocarbon fire is it ignites almost all exposed elements or members completely. So, it is a, I can say it is a full fire. There is no incompleteness, it is a full fire and it ignites instantaneously. There is another concern here. So, there is no time for fire fighting or fire control. because it reaches growth stage very rapidly and sustains that stage for a long duration. Okay. So, that is another issue here. These fire last for very long, in fact, duration. So, firefighting and mitigation task becomes very challenging. Having said this, let us quickly see the chemical compounds involved in such kind of fire. Let us say we will take an example of a hydrocarbon fire where fuel plus air releases products. Okay, that is a common idea. So, let us talk about one specific case: X atom of carbon, Y of hydrogen, Z of oxygen and V of nitrogen present in a fuel gets added with some volume of O2 and O2, that is oxygen present in air. This results in some volume of carbon dioxide of CO2 plus some volume of water, that is steam, as H2O, okay, plus some volume of carbon monoxide CO plus some volume of soot as soot plus some volume of nitrogen. These are the products which are outcome of this kind of fire. So, this is a very typical picture which shows you a hydrocarbon fuel, what happens when it sets to fire. This combustion reaction is often characterized by the following key factors. So, when an hydrocarbon fuel burns, it is an exothermal reaction, it gives away lot of heat and it keeps on burning continuously in the presence of oxygen. You know, hydrocarbon fire, industrial plant fires are generally an open environment. So, there is no lack of ventilation present in this situation. So, it all depends on fuel control fire, and fuel is available in abundance because we have got a lot of large inventory placed in these locations. So, in the presence of oxygen, they keep on releasing steam and other products of gases out, and the most dangerous part is a thick dense smoke developed on the top of this fire. Okay. So, this is another important concern for firefighters. This combustion reaction is often characterized by the following key factors. Let us characterize this combustion reaction. Of hydrocarbon fire. It has got a very rapid temperature rise. Hydrocarbon fires can reach up to 1200 degrees Celsius within 5 minutes. That is the beauty here. Just within 5 minutes, the temperature can touch at least as high as 1000 degrees. This rapid temperature rise threatens structural integrity. Okay. Therefore, you require special design considerations to handle this. The second concern of the character is a high heat radiation. Hydrocarbon fires have very high heat radiation. A typical value is about 160 kilowatt per square meter area. If we talk about ordinary wood or any cellulose fiber developing radiation, a cellulose fiber will radiate only about 50 kilowatt per square meters. So, this is at least 3 times intensive. Okay. The protecting structures from this intense radiation is very critical. Therefore, the resistance of structures to this radiation is very critical. The third characteristic is very high potential for explosion. Friends, we already saw fire and explosions are actually part of the same wheel. Fire can cause explosion, explosion can result from fire or can also cause fire. So, hydrocarbon fires have very high potential of resulting in explosion. Even with very low concentration. That is the issue. So, designing structures to withstand this explosion is again another additional difficulty we have in addition to fire. The next characteristic is the toxic combustion products it releases. It releases toxic products which are harmful for human, like carbon monoxide, hydrogen cyanide, it also releases a black thick smoke which is also very inconvenient and vital for firefighters, because it controls the ventilation, the visibility and approach to firefighters. The next character could be rapid fire growth and spread. Spread of fire. Hydrocarbon fire grows very fast and spreads faster. Because when we compare this with the standard fire curve, it takes very less time to reach its highest possible temperature and then sustains burning at the temperature for a long duration. The next characteristic is the erosive products or erosive effects on fire protection. For example, if we look at jet fire happening from pressurized hydrocarbon, it can erode the passive fire protection coatings. It can make fire protection ineffective as well. The durability of protection systems can be challenged. That is another issue. The next character is corrosion under insulation, which we call CUI. The permanent fire protection systems like cementitious coatings, intumescent paints can trap moisture and lead to CUI. And that can lead to CUI. So, designing systems to prevent CUI while maintaining fire resistance is very critical for long term reliability of structures. So, friends, let us see this curve once again for our knowledge sake. If you look at this curve, one can very well see that the hydrocarbon fire is very rapid and instantaneous to reach the temperature and sustains this temperature burning for a long time. Whereas the Eurocode model 1993 indicates of course the growth stage and sustains fire, but it takes some time to reach this temperature. Hydrocarbon fire is a novel model which is completely different and more vulnerable and more dangerous compared to the standard or the Eurocode fire curve used for design purposes. So, one has got to handle hydrocarbon fire from the original analytical numerical modeling techniques to design the system which are affected by hydrocarbon fire. So, friends, let us come to the summary of this lecture. In this lecture, we learnt about the vulnerability and factors that cause fire and explosion. We also understood important characteristics of fire and explosion. We also learned how hydrocarbon fire could be more vulnerable and bothering because it reaches highest possible temperature, maybe 1000 degrees Celsius, in just 5 minutes. It is a very rapid growing fire which sustains the burning stage for a very long duration, days it burns. So, we have seen also some accidental case histories which help us to understand the reasons of these fire accidents and the consequences caused by this fire, which will make us a trigger of our learning exercise to design the systems to sustain fire for some time. As I said, there is no fire resistant design, fire proof design. You can always make a structure to sustain for fire for some time. We call this fire rating and explosion rating. We will talk about that in the coming lectures. Thank you very much. Namaste.